Roll number 118. Are you here? 118. 88. Are you here?
Yes, sir. 88. I'm here, sir.
So 118.
So, sir, can you hear me?
See that? Yes, I can. Okay, so we'll start from the last class. So for the time being, 88. Please try to cooperate with me so that I can. 88. Arif, is my voice clear?
Yes, I can hear you.
If possible, keep your mic. So basically, in the last class, we did two last slide, that means taking input and output. And if you can remember that we have talked about this in 28. So that is whenever age will be 9. So previously, if I can just give an idea that okay, whenever this line will come to be executed, so at that time it will search for the value of age. So depending on the value of age, basically it does the mix on the monitor. So basically, previously we have seen that age should be 9. So if we things,
Hello,
whenever
sir.
there will be yes.
Sir, we can't hear you, sir, properly, sir. Sometimes your voice is very noisy and sometimes there is misconnection. There is no noise.
কথা অর্ধেক শুনে যে পরে
No
আর শোনা
voice.
যাচ্ছে না।
Okay, is it clear now?
Yes, sir.
Okay, I hope. Okay, let me know whenever you will get. I got interrupted, or you cannot hear my voice. Just let me know. Okay, I'll repeat
Yes,
from the
Okay,
from
sir.
that part. Okay.
yes, sir. Yes, sir.
So basically, what I'm trying to say, whenever you will see in 21 age, then it will search for the value of age. So if we want to print a string, then there should be 9, isn't it? But whenever it will find 9 in age, after that it will search for the offset address. So that is the thing. So that string must end with a dollar sign. So dollar sign is obviously a I should say it is a control character. That means okay, if I write it, this sign is basically, this is not displayed. Basically, this is a control character. This means that the string that I want to print, that has been ended. Is it clear?
Yes, sir.
88.
Sir,
Yes.
can you repeat, sir?
Okay, what I was saying that whenever you will see Okay, I'm giving the example. Let us see, we want to print hello, and after that explanation exclamation sign. So here you can see that this is our this is our string that we want to print, and the last character should be a dollar sign. So if the microprocessor doesn't find that marks there, then it will continue to print. So there should be a this sign should be at the end of the string. That is the rule. Are you getting me? So whenever you have come
Yes.
here, you need to find whatever inside a age. Then you have found that it is 9. Then then that requires that, okay, what is the offset address of the string? Because in a string you have so many characters. There can be so many characters. So all of them. So only the offset address of the first character will be there. So after that the string must end with this sign. So that is a control character. That means that will actually say the microprocessor that the string has ended. You stop printing. That is the thing. So this into h will be having 9. Expect that the offset address of the character is should be stored. Sorry, this should be is it should be stored in dx. So how can we get the offset address of the string into dx? So there is a command called lea. So that is called if I go for the elaboration, that is called load effective address. That means if we say lea, then after that there should be a destination and source. So what it does, it puts the offset address of the source into the destination. So if I write lea dx comma msg, that actually puts the offset address of the variable message into dx. So is it clear about lea?
Yes, sir.
Yes, sir.
Okay. So that is the thing. If I just repeat, then it is load effective address. It is a command that which loads the effective address or the offset address of the source into destination. So as in 21h having 9 age equal to 9 is searching for the offset address of the message or of the string that we want to print. Basically, we use the lea of the message into dx. That means it will load the effective address into dx. That is the idea. Now there is one problem here. So about the initializing of data segment. So try to get this point that we know that we have dot data, and that address of that data segment should be stored at ds, isn't it? Ds is a register. So the starting address should be saved in the ds, isn't it?
Yes, sir.
Okay. So, but thing is that what the DOS, that means the disk operating system, does when a program is loaded in the memory, DOS prefaces it with a 256 byte, it is called program segment prefix, PSP. And the PSP contains information about the program. Okay, just try to get this point clear here. So the DOS places its segment number, that means the segment number of this 256 byte, in both DS and ES before execution of the program. So what happens then? Then actually what happens? And DS does not contain the segment number of the data segment. So that is the important thing. The DS does not contain the segment number of the data segment. So we need to initialize that DS. That means we need to put the address of dot data into DS manually. Is it clear? So basically the DOS does the thing.
Sir, বুঝি
DOS
নাই এটা।
yes, I'm repeating. So try to get. We expect that the segment number of the data, that means after dot data have an address, and that should be saved. That should be in DS, isn't it? Is it clear up to now? The address of dot
Yes,
data
sir.
should be in data segment, isn't it?
Yes, sir.
Yes.
Sir, dot data means all the variable addresses.
Yes. Whenever we're writing a program, there is you can see we have dot data here. So the address is starting at the segment number of this particular dot data should be inside DS. That means data segment register. So thing is that what happens, the DOS, it does one thing, that okay, the it places a program segment prefix. It is called a okay, you can say a part. This is some information about the program. So basically it puts the DOS actually puts the segment number of this 256, which we do not know what is the need for, what is the need of that thing, but the DOS puts the segment number of that 256 inside DS and ES. So basically what we need to do, we need to, what happens, the DS does not contain the segment number of the data segment. That means DS is not containing the value of this data segment, that dot data. It is containing the, whenever the program starts running, or that means before execution it happens. So okay, I'm just, let me complete this one, then you will understand. So
Sir,
what we need to do, we need to put the address of that data into DS manually. We need to correct this thing. So basically, this is the assembler translate dot data into a memory segment number. Basically, two instruction is needed because you cannot write move DS then address of data, because it is not allowed that you can move a location into DS. It is not allowed. But what you can do, just you can use move AX comma add data, then move DS comma AX. So it actually the problem that was happening, that means the data segment register is not having the address of the dot data, can be rectified by using these two lines. And whenever you will have dot data, you will have any variable or any data, you need to initialize your program. The first two lines of the program should be these two. Is it clear?
Yes, sir.
তো তার মানে হচ্ছে আমরা আমরা যখন এই ডট ডাটা সেগমেন্টটা ইউজ করব আমাদের প্রোগ্রামে, আমার এই দুইটা লাইন ইউজ করতে হবে।
That means you are initializing the data segment.
ওকে স্যার।
You're initializing, you're putting the address of the data into DS. That means you're doing this manually. So DOS is doing something wrong, so you're just making this correct by yourself. Is it clear?
ইয়েস স্যার।
I hope. Okay, so if I say that then this, first of all, you should write this two line, because you have a data dot data portion. And then this, if you want to print something, then what should be the three lines? So whenever it will be executing this one, you should search for it. Then when it is 9, it will search for the offset address of the message to be in DX. That means load effective address. This is the destination, this is the source. That means the offset address of MSG will be moved to DX. So whenever in 21H will get the offset first offset address of let us say hello. So it will get the offset address of this one. Then it will print up to this mark. This mark will be printed. So before this mark, all the characters will be printed. So let us go to the next line. So from the last class, we know that dot model is small, then dot stack 100H, then dot data, dot code, and this is the program that we have seen the last class. So now we want to print a string. So this is message db hello, then a $sign to end that one. And after that, initializing your data segment. Then after that, you have written LEA, then just printing that thing. So that is the idea. So if you just run this program, that will show you the program that you have seen before that. Okay. Okay, let me run this here. So you just run this, and you can see there is a hello here. So it has been printed. So whatever you'll be so whenever you will be you want to print something, then this is the three line you need to write. And that means you need to load the effective address of that particular string to DX and moving 9 to AH and then interrupt 21H. That will invoke the particular DOS that is responsible for printing the string that particular routine code of DOS. So that is the idea. And if you have more than one, then you need to again go for interrupt and again do all this thing. So
Sir, what is the
if I
function of
say
force
that
CH there?
what is the okay 35H, isn't it? Sorry, 35,
Yes, sir.
not H. Are you 35?
Yes, sir.
Ron? Or who has let's see here? Tell me
Sir,
your ID,
isn't
please.
sir, isn't it
48.
moving the no sir, the question was asked by 35, sir. ID 35.
Okay. Yes.
Sir, sir, isn't it moving the hexadecimal value to the 4C hexadecimal value to
No, I have explained this in the last class. I have said that this is basically this
to
actually returns the control to the DOS. Whenever you are writing in 21H, that will search for the value of H, and that will whenever it will get 4CH, then what it will do? There is a particular thing. It will end the current process. That means it will end the current process of executing the program, and it will return the control to DOS, disk operating system.
yes, sir.
Yes. So is it clear? 35.
Sir, if I
Yes, sir.
somehow don't give it at the last and give it in the middle of the code, like after the interrupt of 4ch, if I put some another command, will it be executed?
So you are saying that okay, you have written move h comma 4ch, and after that you have written move let us say dl comma let us say a, and then you have written in 21H, isn't it? Is your question something like
No, sir.
this?
No, sir. My question was like,
Then
first I move AH, comma 4CH, then
you
I
want to
interrupt.
give it here.
Yes, sir. Yes, sir.
So you can just run that one. Okay, that is, you can just put in the here. Okay, let me. Good question. Okay, it has been, the program has been transferred the control. So you see, there is nothing is printed. Is it clear? So
Yes, sir.
whenever you will write this, the current process will end, and that will give give the control to the operating system or DOS. So these lines will not be executed. Is it clear?
Yes, sir.
Okay, then the next thing that I wanted to show you is that basically this is the structure that you can follow. This is a structure of a program having dot and everything. So basically your variables should be here, and you write your code here. Other things will be same for all the programs. Okay.
Yes, sir.
Okay, now this should be done. Okay, let me a case conversion program. That means the program that we have seen from the beginning of the class, that if we give an input of a lowercase character, then that should be translated into a uppercase character. So how can we do that thing? So that should be in this is the thing that we can show in the monitor. That means enter a lowercase letter, then a colon. After that you will give the input, and next line it will print in uppercase it is, then a. So that is the monitor output that we want. So that is the problem that we have to solve. So if I just subdivide this thing, then you can say that the program begins by displaying the first message and then read a character. So every time try to follow this thing. Whenever you will try to do a program, subdivide that thing into few subgroups or few sub problems, and then solve those sub problems and add one by one. That will help you to debug and do the course without error. So you can see the first we need to show the message and then we read the character. Then having read a lowercase character, the program convert it to to uppercase. That means whenever you're having a lowercase, then we need to convert from the higher uppercase to the lowercase. Lowercase to the uppercase. So how can we do that thing? How can we do that thing? So you can see that is the ASCII code or ASCII values of the characters in hexadecimal. So whenever you will see there is a conversion or there is anything we need to relate from the characters, then come to this particular code or this particular chart. So here you can see we need if we have A, then we need to convert it to uppercase A. So what is the relation between lowercase a and uppercase A? Anyone? Can you tell me?
20.
Huh? 20.
Subtract 20.
That means, yes, even if you come up to Z, so the relation between lowercase and uppercase Z is the difference of 20h. So if you want to move from one to other, then you just add or subtract 20h. That will give you the conversion. Is it clear?
Yes, sir. Yes, sir.
Okay. Okay. So then display the second message and then after that print the converted uppercase letter. So that is the 5 tasks that we need to do. So here one idea is that, so we will show the first message. So that is enter the letter in the lowercase, that is message 1. But message 2 and character we can do in other way also. We can obviously do in other way. But is a shortcut that has been followed in the book. Okay, after writing this one, what happens? Basically after that you take an input here, and whenever you want to show the next message, that means you are here now after taking input. Now you want to show you want to go to the next line and show the message and show the converted one. So this can be done together. Print message 2, first of all it will go to the next line. So from here it will come to the next line. After that it will print up to this, it will print up to this, and after that what happens? After that your character, then you have uninitialized that one, then you have give the end sign. So after conversion, you move that sign in that A, uppercase A into character. Then you print this message. That what happens? This will print here, 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 up to here, and this will print the character. After that, it will end. That means it will show the whole thing together. That then it will get the $sign. So things will be more clear when you will be when we will see the program. So here we have obviously the data segment. We need to declare all the variables, and then we have initialized the data segment. After that, we have shown the first message. So after this message, what will be printed? 150, 115. Yes.
Yes, sir.
What will be printed after this line?
Enter
In
the
letter in
lowercase.
lowercase.
Lowercase. So it will end because there is a
Dollar
sign
sign.
there. After that, yes, $sign. So after that, we take the input using AH and in 21H. Then by these two line, basically we are. So after taking the input, AL is having that particular value. Let us say A. So now we are subtracting AL comma 20H. That means now AL is having the ASCII value of A. That means if it is 61H, it is 41H, isn't it?
Yes, sir.
Then you're putting that particular AL, that means A, into the character that was uninitialized. So now your CHAR, that is that will have the ASCII value of the capital letter A. So now whenever you are printing that message to, it will start from here. That means it will go to the next line A. After that it will end. Is it clear now?
Yes,
Sir,
sir.
hello, sir.
Yes.
স্যার আমার স্যার নেটওয়ার্ক অনেক প্রবলেম করতেছে স্যার। আমি স্যার ফোনের ডাটা দিয়েও দেখলাম, আবার হচ্ছে ওই ওয়্যার্ড কানেকশন দিয়েও দেখতেছি। এখন স্যার মানে আমি স্যার কিছু বুঝতেছি না আসলে, কথা কেটে কেটে আসতেছে তো বারবার মিস করতেছি সবকিছু।
Okay.
স্যার মানে আমি
We
শুধু
normally record the second class. So you can obviously go through that one. By tonight you will get that thing. Otherwise I do not know how to do it.
স্যার এখন জাস্ট আমি স্যার বসে থাকতেছি, মানে স্যার কথা বারবার মিস করতেছে নেটওয়ার্কের জন্য।
You are 88 or
স্যার 138 স্যার।
138?
Yes sir.
Okay, what do you want?
এখন স্যার আমি বসে থাকতে পারি, অথবা স্যার মানে পরে আর কি আমার তাহলে ডাবল ক্লাস করা লাগতেছে স্যার। এখন স্যার আমি মানে লিভ নিতে পারি?
Okay, it is up to you. No problem.
Okay, let me add over here 138. You can leave, but remember, you will not get a chance in the question answer session. So your class performance will be at stake. And I can see that in the last, I mean, that's totally up to you. Okay.
স্যার আমি স্যার ইন দ্য লাস্ট এর পরে আর শুনিনি স্যার।
In the last class, you were given, I mean, you were asked a question and you could not answer.
Sir,
like I don't know that.
NOP,
Yeah,
sir.
but I know, but over here I can see that the mark is that you did not, you 138, right, Sakib?
Yes sir.
Yeah, but it shows that you could not anyway. So I don't
sir,
know
I
today.
answered
I mean,
NOP,
whether
sir,
you
sir.
get a chance or
Sir,
not.
I answered NOP and it was the right answer.
I think I
Sir,
did
as far
not
as I
consider for NOP. I think there was another question that was asked to you.
No sir, that
অন্য
was the
কোনো
only
question
question
ছিল
sir. NOP না স্যার, এটাই জিজ্ঞেস করছিলেন স্যার।
It's up to you, okay? মানে আজকে চান্স পাইতা কিনা আমি জানি না, যেহেতু as I ask randomly, so it's totally up to you whether you want to stay or not.
Okay sir, I think I can
Okay, we
wait
have
for several minutes.
other topics here. So these are, you already, if you have done all the course, then you already know how to do all these things. So here, translating a higher level language into assembly code, how to do that thing. That means so I'm just showing you here.
আগের
So
প্রোগ্রামটাতে একটা কোশ্চেন ছিল স্যার।
yes, obviously.
স্যার আমরা হচ্ছে
Go
ক্যারেক্টার
on.
ডিবি যেটা ইনিশিয়ালাইজ করতেছি, মানে আনইনিশিয়ালাইজ যে ক্যারেক্টারটা ভ্যারিয়েবলটা নিচ্ছি, ওইখানে আমরা লাস্টে যে ডলার সাইনটা দিচ্ছি, এটা কেন দিচ্ছি? কারণ আমরা তো কোনো ভ্যালু দিচ্ছি না ডিক্লেয়ার করার সময়।
No. Thing is that 9, then it will that dx is having this the offset address of this 0dh, and it will print one by one all the thing until it gets a dollar sign. And you know that these are saved in the data segment sequentially. So after that colon, you will get the character. You have initialized that you are giving a dollar sign. So whenever you are giving a value into that character, then that is getting that particular value. So it will print that A. After that, you will get is the control that okay, I need to end here. So here also you can see these are the ASCII values. These are not the same inside a string, and these are saved sequentially. I have told this in the last class. Is it clear? 15 or who has asked? 15?
Yes, sir.
Okay. So there are other topics. Then if these are the variables A, B are let us say these are the variables. Let us say A, D, D, or use here. So how can we do this thing and do this thing? Because we cannot move a variable to variable. Then what we can do? We can move to AX and then AX to B. So that is corresponding to A equal to B. And then you can see by yourself how to translate that higher level language to assembly language. Just for your practice, okay, you have seen that A is equal to 5 minus A, but in assembly language you need to move 5 into A, then subtract AX minus. So you are moving AX, so AX is having 5 minus A, and then you're moving that AX into A. So that is giving you this one. So I'm not explaining the next one. These are same, but you can do by 2 line. That means my A will give you minus A, and then when you add 5 with that, so finally you will get 5 minus A inside A. So that is the same been shown here. And other topic that has been shown here is basically you just try to listen what I'm saying. Normally we translate the assembly code into machine code using MAS. For this one, MASM. So now in Windows 10 and even Windows 7, 8, we do not have that package. So basically, whenever we'll be using emulator, we need not to go for this .exe file. So whenever you will be .exe file, that can be run in the program. But using emulator, we can skip all these things, creating the obj file and all those things. So I have not explained here. And whenever we'll see the hardware implementation or one setup of that one. So if we see that thing, then we may need this thing. Then we'll explain that at that time. And using Windows 10, we have a software called DOSBox. So DOSBox can be used to make a virtual disk operating system that can be used to make all these steps. But maybe in the chapter 3 we're in 3.10 so far I know, or you can just see that how to create and run a program. There is a chapter, but as long as we are using emulator, we can skip this one for now. Is it okay?
Yes, sir.
Okay. So then your task for this chapter. So we have concluded this. You need to
স্যার মাঝে
yes.
মাঝে স্যার আপনার কথা কেটে যাচ্ছে।
জি স্যার, অনেক কিছু মিস হয়ে যায় মাঝে মধ্যে।
কতটুকু শোনো নাই এটা বলতে পারবা, মানে কতটুকু
স্যার
শুনছো?
ব্যাপারটা হচ্ছে মাঝে মাঝে এমন হচ্ছে 2-3টা ওয়ার্ড শুনতেছি, তারপরে 2-3টা ওয়ার্ড বন্ধ যাচ্ছে, এরকম হচ্ছে।
আচ্ছা, এটা কি সবার ক্ষেত্রেই হচ্ছে, বাকি আর কারো ক্ষেত্রে হচ্ছে কিনা?
ইয়েস স্যার, সবার হচ্ছে স্যার, মাঝে
স্যার
মধ্যে হচ্ছে।
সবার ক্ষেত্রেই মনে হয়।
ইয়েস স্যার।
আসলে বুঝতেছিলাম না আমার প্রবলেম নাকি সবার, এজন্য বলি।
আপনি যেমন স্যার এখানে যখন এক্সপ্লেন করতেছিলেন উইন্ডোজ
জি
10
স্যার,
আর তারপরে কি
এইখানটাতে
বললেন
স্যার
স্যার
কিছুই বুঝি নাই
দুইটা লাইন
তো।
মিস হয়ে গেছে।
আচ্ছা আচ্ছা আচ্ছা, জাস্ট আমি একবার বলতেছি এই জায়গাটা। So thing is that uh, about this topic, uh, how to create and run a program. So whenever normally what we do, we write this program in a text editor. That means it can be a notepad or anything. We write this code in a text editor. After that, we translate that, and there are some steps. There are some steps to make the program executable. So the emulator does it by itself. Emulator is a I should say it is a software of 8086. It's a simulation to do the simulation we are using emulator. So it does all these steps, but it does all this. But if you want to do manually, that if I have a text editor, then how to translate, how to make that executable using our operating system. So basically there is a assembler. We normally use a assembler called MASM, Microsoft Macro Assembler. Is it clear? Microsoft Macro Assembler is an assembler by which we translate these codes into machine code, and then we're using some step we make that program executable. But for the time being we do not need this one. In Windows, basically Windows 10, 7 and 8, this MASM does not work. So we may need DOSBox, that is another software. So all these things, maybe whenever we'll see the hardware, so 8086 in practical lab, then maybe we use this DOSBox and all the things uh, to see these steps. But for the time being, whenever you are using emulator, we do not need these steps. But as it is in your book, I'm just saying that, okay, we have not skipped this one, but for the time being, we do not need this one. Is it clear?
Yes sir.
Okay. Now, these are the tasks. So now I think we can move to the today's class. Obviously, this was the left out from the last class. Okay. So in this lab, we'll see two things, very easy things. Just try to concentrate, and I have made the slides such that you can understand very easily. Just give a concentration. Uh, that will help you. Thing is that I will ask a few questions here, so you need to answer, and that will be considered as your class performance from lab 4. I'll be asking questions from lab 4 basically, so try to be concentrated. I'll give you some problem instantly and ask randomly, and you need to answer all those questions to get the class performance of today's class. Is it okay?
Yes, sir.
Yes, sir.
Okay, our first topic is
Sir, one of the
I cannot hear you.
sir, one student message in the chat box, sir.
Yeah, I have
Facebook.
seen that thing. Yeah, I have seen. Okay, so this is basically chapter 8 and this is chapter 5. So very small chapters. We have integrated all those things in a single one. So we have heard about the stack, and last class I have said about the procedure that after writing main, then you have written np, uh, then your other procedures can go here and then end main. So can you remember that part?
Yes, sir.
Yes, sir.
So your main proc has started here. So these are the thing. Then your other procedure, the other procedures can start. You can write here. So we'll see all the things. So first of all, let us start with stack. So it is a temporary storage of data and addresses. So last in first out. And by using dot stack, then 100h, we are keeping that much of memory aside for doing the stack operation. And we'll see that how we can perform the stack operation, and also we can see how the microprocessor use the stack to do its own works. Okay, so basically so it is just SS will get this segment number of the stack whenever you load the program. So even in the emulator, we'll see one demonstration. So how the things works. Okay, so then in case of stack, you know that SP is the stack pointer. So stack pointer points to the current position of the stack. So it initializes, if it is 100h, then it is initializes to 100h. Then it actually decreases from 100h. So whenever you want to keep there something, SP will decrease and keep it will point. Okay, in the next slide it will be more clear. Just try to understand that whenever SP is pointing 100h, that means there is nothing into the stack. And these are the addresses. So it will start with 100h.
sir.
জি স্যার কথা শুনি নাই
Okay, what is the last thing that you have
108.
heard? I was saying that I should know why my internet connection is not stable today.
We are also facing the same problem in the last class that we did today in Rulamin sir's class.
Oh, okay. So, okay, let's try to cope up with this one. So, whenever I'm getting interrupted or my voice is lagging or interrupted, then try to tell me, sir, I'm not, we are not getting it. So, I'll repeat that part. So, today's lab is not that much more. We do not have that much content, so maybe we can finish within the time. Okay.
Yes, sir.
So basically, SP is the stack pointer. Okay, these two lines, I'm explaining these two lines in the next slide. So that will be more easier. So here, it is basically your stack memory segment. So whenever this SP, where we have kept 100h aside for stack memory. So the stack memory looks like this. That means SP you want to put something in the stack, it will decrease the value. It will decrease the value one by it is obviously and you can see 100h, then FE. That means each of these one are basically what? Sorry.
So it's decreasing by 2.
Yes, it is decreasing by, like I'm just all the operations that you are doing in the stack. You will have. I'll show you push, pop. All of them are word operation. You need to decrease by 2,
কথা
isn't it?
কেটে গেছে পুশ পপের পরে
I was saying push and pop. We'll see these two instruction, and you will see that the push and pop, these are word operation. That means you can save in the stack by it is a word operation. That means you should save 16 bit together. So this structure that we have shown here, for convenience, that it will decrease by 2. Each time it will decrease by 2.
ওকে স্যার
So whenever SP is pointing to 100h, that means the stack is empty. There is nothing in the stack. So this particular line I'm explaining after 1 or 2 slides. Okay. So here push and push F. Push source. What does it do? SP will be decreased by 2 and a copy of the source content move to SSSP. SS is the segment number of the stack segment and SP is this one. So if I go for push, it will decrease by 2. Okay, I will show you the slides so that will be more clear. So just try to remember we have 2 steps, step 1 and step 2. And if you write push F, that pushes the content of the flag register. We know the flag register is 16-bit into the stack. So push F and push, we have 2 commands here. I'll show you everything. Just at the end, you'll see all the things. Then pop destination. So it will copy a content of SS and SP to the destination, and SP will increase by 2. And pop F will pop the content of the top of the stack into the flag register. Okay, just try to follow this slide here. Now, if we have push AX, that means push source. SP will decrease by 2.
সোর্সের পরে আর কিছু শুনি নাই।
Okay, okay. Okay. Okay, I'm repeating from the source. So whenever there is this push AX, then you see that push, after that there is a source. That means we want to put the content of AX into the stack. So there are 2 steps. The first step is that SP is currently 100H. It will decrease by 2. That means it will be pointing by decreasing 2. After that, the content of AX will be saved to that particular SP. That is the idea. I'm doing again. So first step is SP will decrease by 2. Second step, a content of AX will be saved in there. Again, push BX. SP will decrease by 2. And a portion of the content of BX will be saved into there. So is it clear about push?
Sir,
Yes, sir.
kindly repeat, sir, please.
Okay, I'll repeat. I'm coming from here. So SP is initially 200H. So there are 2 steps. First, the SP will decrease. Then a copy of the source content. That means if AX is a source, then the content of AX will be saved in that particular value of SP location. So see, SP will decrease by 2. Then a copy of AX will be saved into that particular location. But 100H will be vacant all the time. Whenever SP will be
Whatever
to other thing.
Sir,
Yes.
whatever SP will be এরপর শুনি নাই স্যার।
Yes.
Sir, whatever SP will be এরপর স্যার।
Okay, okay. I'm repeating. So whenever SP will be pointing to 100H, then the stack is empty. And other than 100H, whenever SP will pointing to other addresses, this is called top of the stack. Now push BX, SP will decrease by 2. Of BX will be moved to that particular address that is pointing by your SP. So is it clear up to push? The push command is clear, isn't it?
Yes, sir.
Now, if we write push F, there is no operand here. What will it do? So SP will decrease by 2, and here content of the flag register will be here. Is it clear?
Yes,
Yes,
sir.
Okay.
Robiul.
Yes.
Okay, if it is clear to everyone, then let me ask a question to. Let
Sir,
me
I
go.
was disconnected for a second. Can you repeat the push process?
আচ্ছা রবিউল আরেকবার কথা তারপর কোশ্চেন করছি
Okay. So we have started from here. So whenever SP is pointing to 100H, the stack is empty. Now there are two steps for push AX. So whenever this will execute, this will do by it will do two things. The SP will decrease by 2, and now SP will be pointing here, and the content of the source will be moved to that particular location, and we call it the top of the stack. Here again push BX, SP will decrease by 2, then the content of BX will be moved to that particular location. Then I have said if we write just push F there, what will happen? SP will decrease by, again it will decrease by 2. The content of the flag register will be pushed here, will be saved here.
okay so let me ask a very small questions. Let's start with 155, the person who is having a bit of problem. Are you there? 155 ID 155 Raihan, are you there? Okay, most probably he is not there. Okay, let me go to 16 batch ID 147 Niloy, are you there?
Okay, Niloy is not doing the class. He already informed me.
Niloyo nai, Raihano nai. All right then. So let's move to ID 118 Fariha, are you there?
Yes, sir, I am here.
Okay, so let me ask you a question. Assume the contents of the BX register, which are 5, 6, 7, 8, they all are in hex number. Okay, this is your assumption. All right, the contents of BX registers are in hex, exactly. Yeah, something like that. So when you're writing push BX in the current scenario, your contents of BX register will move to 00FC address, isn't it? Is it clear up to this?
Yes, sir.
If I ask you what is the physical address of 78H only of the BX register, what will be your answer? What is the address of 78H of the BX register? What will be your answer? Of 78H only.
Sir, will it be FC?
Okay, and what will be the address
So 0,
of
0.
56? Okay, wait. So I will continue the question. So the question is continued to 009. Alice, are you there? Huh?
Yes, sir, I'm present.
Okay, so the same question to you. What are the addresses of 56H and 78H? Tell me the addresses.
Yes, sir, I don't know, sir.
You don't know. Okay, let's move on to Sakib 138. Aso?
Yes, sir. Yes, sir.
Bolo, what is the address of 56H and 78H?
The physical address.
Physical address.
Not
physical address actual physical address, the SP address, exactly, for where the SP is there. Yeah, that address where Robil just showed. 16 is open. Anyone who can answer?
Yes, sir.
ID কত?
The 50
দাঁড়াও
16 batch 35.
16 ব্যাচ 35 এ ছাড়া আর কেউ আছো? সওয়াত
Sir,
ছাড়া আর কেউ?
Yes, sir.
115 sir.
134.
দাঁড়াও 115 ছাড়া আর কেউ?
So 134.
134. I'm trying to give a floor to someone who did not answer. যারা যারা বলতেছো সবাই আগে আনসার করছো. So let me go to 16 batch 35. Okay, please. 16 batch 35. Soad, right? 16 batch 35. ও আবার কই চলে গেল? ওকে, আরেকজন জানি কে বলছিলা?
Sir, 115.
115. Okay, give the answer.
Sir, 56 will be in 00FC and 78 will be in 00FD.
একটু ভুল হইছে মনে হয়।
Sir 00FB তে হবে।
Sorry sir, D তে হবে, D তে।
115 বলো, 115
Sir,
আবার বলো।
FE minus 1 মানে হচ্ছে D তে যাবে একটা আর C তে যাবে একটা।
হ্যাঁ, C তে কোনটা D তে কোনটা সেটা আমাকে বলো।
C তে 56 আর D তে মনে হয় 78।
Sir, I'm good. Yes, sir. 144, sir. Can I answer, sir?
FD তে যাবে 56।
এক্স্যাক্টলি, FD তে যাবে 56,
FC তে 70।
FC তে যাবে 78। কে বললো এটা?
So 134।
134।
134।
ওকে, এর আগেরটা জানি কে বলছিলা? একটু ভুল হলো।
115।
115। তুমি বুঝছো ভুলটা কোথায় করছো?
জি স্যার, হাই বাইট আর লো বাইট দুটো
হ্যাঁ
জিনিস।
হ্যাঁ, এক্স্যাক্টলি। যারা বুঝো নাই, প্লিজ মেক শিওর ইউ আন্ডারস্ট্যান্ড this portion, okay? 00FC are not two different addresses, they are the exact same address. And whenever Robbie already said that it will be decremented by 2. By 2 means what? By 2 bytes. So definitely there are two separate addresses over here. All right, and the contents that you are moving are all 16 bit. That means 2 bytes. So definitely they need 2 byte addresses. That's why every time your stack SP decreases by 2 so that it can allow you to store 16 bits at a time. Robil, please continue.
Sorry, sir, my internet connection got disrupted.
Okay, now we'll see the pop instruction, and we know that pop, and after that what is written, that is your destination. So SP, let us say SP is currently pointing to your this address. Now what will happen whenever this line will be executed? There are two steps. First step is that this content will be moved to CX, and second step, SP will be decreased by 2. Sorry, increased by 2. This time increase.
Sorry, it does the reverse operation of push.
Yes. So whenever you are putting there something, you need to obviously pop that one. For you're putting that to save that one. Whenever you need that thing, but try to get this thing clear. This 5, 6, 7, 8. If you can remember, initially it was in BX. So it is not mandatory that you need to pop that to that particular one. Whatever you will be writing here, that content will be popped to that particular register. That means you're writing CX, this particular value will be popped to CX. It is not mandatory that from where it has come. So push and pop has only one operand. Push something means this, that is the source from where you are saving to stack. Pop destination means you are popping the value, you are retrieving the value from the stack to that particular register. Is it clear?
Yes, sir.
Okay. So again, whenever you are going for pop DX, content of that particular location will be going to DX, and SP will be decreased by 2. Now it is empty.
Sir, one question.
Yes.
So push and pop, they always operate on the highest available stack memory.
Yes. Without 100H, you can say.
Yes, sir.
More general way of saying is they actually depend on SP. Don't say highest in stack. I mean, whatever you said is right, But the best way to see this is they depend on the address that is being pointed by SP.
Yes, sir.
So it will decrease or increase by 2, and then whenever it will be pointing to there, it will do the. But you have seen that these two are reversed. That in case of push, SP will decrease first, and in case of pop, SP will decrease after moving the content. So that is the idea. Is it clear now?
Yes, sir.
Okay, now we're going to see the procedure. So that is the same thing. Then whenever you have function, you call that function, you will be giving the control to that function, to that procedure. Then after completing that, I'm saying function so that you can understand. So after completing that function, it will come to the next instruction from where you have called. So I'll explain that part obviously. So how to write a procedure in how to write a procedure. What is the this is the idea. So you need to give a name, then this proc, and after that you need to write the type. So type can be near and far. Okay, after that, after writing the procedure, you need to write return. After that, name 1 and p. That is the structure of writing any procedure. So what is near and what is far? So near is when your procedure is into the same segment of the main one, and far is when it is in a different segment. So basically try to get that for our case, whatever the program that we will be doing. So near will be enough, and if you do not write anything in the type, that it will consider it is a near one. The type is near. So you can say these three lines are the structure of a procedure if you want to write any procedure other than main. So obviously I'll show an example.
Sir, what does near and far mean?
Yeah, that is I say that whenever you write this, these are the types. So you can write okay, name 1, proc, then near or far. So for our model is dot model is small, isn't it? That means we have a one data segment and one code segment. So basically this near is not needed. Whenever you omit this type, you do not write anything, it consider this is a near type. So for our case, we do not need far. That means whenever they are in two different segments. Is it clear?
Yes, sir. Yes, sir. Clear.
Okay, now you can call that one using the name or the address expression. Okay, let me go to the next slide. Okay, one thing is here, return pop value. So here there is optional thing, then you can write 2, 3, 4, 5, something like that. So I'll explain that thing in the next later slide. So this is the structure. Try to get. This is our main procedure. Then after that we are getting an instruction. Okay, I'm going to procedure 1. The name is procedure 1. It will go from this instruction, it will go to the first instruction. After completing all those things, whenever there will be a return, it will come back to the next instruction after the call. Is it clear? Just simple as it is.
Yes, sir.
Okay, how the microprocessor does this thing, let's see. So here, let us say you are here, you're executing this one. That means your IP will be pointing to the next one, next instruction. So when this will be executed, this line will be executed. So try to get, this is the address of this line. So this 12 is the address of the next instruction, and 200H is the address of the first instruction here. And also we have other things here. So okay, so the steps whenever we are here, we are executing this thing. So at that time, this stack in the stack SP will decrease by 2, and a copy of IP will be saved there by the microprocessor. And then IP will be moved to the first instruction of the procedure 1, that means probe 1. And after that, after completing that thing, whenever we have completed running whole program, then during return, okay, here one thing, okay, that is okay. Yeah, maybe I have done one mistake, but thing is that the IP value will be moved from the stack, and after that SP should increase. That should be the CDI. So basically, whenever you are returning to the next instruction, so idea is from here you are going here. So how to come back to this particular position? So basically, the microprocessor use the stack segment to do that thing. IP will be saved here, and whenever it will be returning to there, so IP will be loaded from this particular value.
স্যার আরেকবার বললে
Is it
ভালো
clear?
হয় স্যার জিনিসটা।
আচ্ছা, আবার বলতেছি। So whenever you are executing this line, what will happen? A copy of IP will be saved into the stack. Okay, a copy of IP will be saved in the stack, and the IP will get the value of the first instruction of procedure 1, or the name of that one. We are calling that function, isn't it?
Yes, sir.
So that will go to the first instruction. IP will be having the first instruction, the value of this first instruction. After completing the whole program, whenever it will get return option, the return instruction, what the return instruction will do, it will take that IP value, loaded into IP, so that it can come to the next instruction after the call. Are you getting me?
স্যার ব্যাপারটা কিরকম যে আমি যখন কল করব প্রোগ্রামটাকে তখন হচ্ছে যে 0012 এর ইনস্ট্রাকশনটা এটা কাজ করবে না, জাস্ট এখানে আইপিটা ওখানে যাবে, তারপরে আমার প্রোগ্রাম ফ্লোটা যাবে হচ্ছে 0200 তে, তারপরে এটা যখন শেষ হয়ে রিটার্ন করবে তখন এটা 0012 তে যাবে।
হ্যাঁ, সেটাই, মানে জাস্ট আই এম শোয়িং হাউ দি মাইক্রোপ্রসেসর ওয়ার্কস ডিউরিং দি কল. So it saves the IP value because it is pointing to the next instruction. It saves the IP value in the stack. After that, whenever it will be coming back after return, it will pop that from the stack. That is the idea.
Yes, sir.
Is it clear?
Yes, sir.
Yes. Now here, just few things that
100H quadratic always empty থাকে. Always to SP.
Yes, that will be always empty. Whenever you want to push something, SP will decrease by 2 first. Then that will be saved. That means even if there is value in the stack, but there will be no value in 100H. But whenever SP will be pointing to 100H, that means it is empty.
Yes.
Then push, pop are word operation. I have said this before. These are word operation. You cannot move. You cannot write push DL, or you cannot write pop DL. You cannot pop or push to 8-bit registers.
Question, sir.
Yes.
Sir, in the previous slide, is the stack initial value is constant or variable for operations? Like zero.
Okay, later. Okay, I'm taking this question. So it is considered that SP has been here, but if by any chance you have pushed something here, then SP can be here on here, isn't it?
Yes, sir.
So then the next one after the whenever it is pointing to here, so the next whenever you are going to the whenever calling something, so it will move, it will decrease by 2 and pointing to the next one. So that depends on, so we have assumed that the SP was empty, that means the stack segment was empty. But if you had pushed something there, obviously SP will be pointing to that particular address. Is it clear?
It will be decreased by 2 and The pointing
it
to
will be
the
decreased by 2 and IP will be saved there. This time.
sir, will it be pointing to the address which was decreased by 2 or the initial address, sir? Which
So
address?
you are talking about this call or
Yes.
which one?
Yes, sir. The call. You
Yes,
said
it will decrease by 2 first. It will decrease by 2 first.
Okay, sir.
Yes. Like it is a push operation. Like the push operation. Okay.
Yes, sir.
So here another thing is that you cannot write immediate, you cannot push immediate values. So in 8086 it is not allowed, but later version of the processor allowed this thing. Say you are saying push 3 or 4, 8, something like that. All these constant values are not allowed to be pushed. So it is not allowed in 8086. Okay. Another thing is that you can see in 21H. So basically that is an interrupt, isn't it? So it does the same thing. So if I just have to clear this thing. So it does the same thing. That means whenever you are writing in 21H, so the next IP will be saved in the stack. And in 21H by here, whatever there will be in H by that thing, so IP will be pointing to that particular memory where, let us say, you want to read something or write something that is in the DOS or in the BIOS. So IP will be pointing to that. After completing that routine, that means taking input, printing something, printing character, or printing a string. After that, whenever it will come back, it will pop that IP value so that it will come to the next line. So if you have something move or move L comma something or something like, so this is doing the same thing. It is calling that particular routine by saving next IP into the stack. After completing that particular routine of DOS or BIOS, after completing that thing, then IP will be loaded with this particular value. Is it clear? Are you getting me?
Yes, sir.
Okay, just one thing I want to mention here. So let us say you are, yes.
ফ্ল্যাক্স রেজিস্টারটা এখানে কোন জায়গায় কাজ করতেছে?
ফ্ল্যাগ রেজিস্টার কোথায় কাজ করতেছে?
Yes.
Have I said anything about flag?
মানে উপরে লেখা ফ্ল্যাক্স রেজিস্টার ওটা কি মানে এমনি জেনারেলি লেখা নাকি?
Oh, acha, sorry. That is my mistake. So basically that should be procedure. Okay, that is my mistake. I have okay, I have made this slide that it should be all the procedure. So from here, basically a flag register, basically our next topic is flag register. Whenever I made this slide, maybe I forgot to remove that part. Sorry for that. Okay, well, one thing I want to mention. Okay, I want to ask. This can be a question to. Okay.
33 ke kar Robul 33.
33. Are you here? 33. 33.
Yes, sir.
Okay, let us say we had an instruction here, push let us say X. What will happen when we are here? That means your I. Okay.
Sir, can you repeat? I couldn't hear.
Yes. I will repeat. So in this position, let us say your you have one instruction here, push AX. So what will happen? Let us say your AX is having 1, 2, 3, 4. So what will be the change in this stack? So I'm just removing this thing. Now SP is pointing here, and do not consider this IP. Now we are here. So whenever we are executing this program, we have a push AX. Now tell me what will be when it will be executed, what will be the change in this stack?
I don't know, sir.
You do not know. Okay.
34 aja.
34.
Sir, by executing push AX, it will move two addresses upwards because that's how it's executed. Sir,
Then?
and sir, if the IP is 0200 and if we select push AX, then 0200 minus 2 and 0200 minus 2 will get a different IP, and 1234 the address of AX will be settled within that IP. So if 0200 minus 2, we get two intermediate states of the next two IPs. So 12 will be within the forward state and 34 within the backward state.
So will there be any change in this segment?
In this, no, sir.
Okay. So we can move to another one, Arif.
আচ্ছা নেক্সট তাহলে জিজ্ঞেস হচ্ছে 89 নাসের।
Yes, maybe you have got the question, isn't it? Okay.
48 আসিফ।
Yes, sir.
বলো সেম কোশ্চেন আনসার করো।
Sir, is the question is will there be any change in the stack segment?
Like I'm executing this thing.
Yes, sir.
What will happen whenever we're executing this thing, push AX? So obviously there will be change in the stack segment, obviously. But what will the change?
Sir, in the previous state, after forming on the push AX, after forming the push AX, sir, the address will be first kept on the two upper level by two segment, and then it will be called upon the procedure, sir. Before it is called, it will be stored in the two upper segments.
Okay, there are addresses here. Tell me the address name and the content.
Sir, it will be maybe, sir, is there any address on the upper level of 00FC?
অত স্পেসিফিক হইতে হবে না তোমার, তুমি এখানে যা আছে সেটা দেখে জাস্ট আনসার বলো। অত ভিতরে তুমি জাস্ট নরমালি বলো যে এক্স এর কন্টেন্টটা কোথায় যাবে আর কি হবে, জাস্ট এতটুকু বলো।
00FB, sir. It will called upon 00FB, and then it will be on the procedure. Then it will be called on the procedure.
Okay. Arif, open করে দে।
আমি এটা বলছিলাম, ওপেন করে দে।
Sir, can I say?
Sir, yes, sir. 1, 2, 3, 4, 2.
বলো আইডি বলো কত?
92 sir.
90
Sir, 149.
Sir, 140, আচ্ছা হ্যাঁ 149 বলো।
Sir, it will go to the 00FC as this is as the SP is 00FE, then two address upward will be 00FC. So it will push to.
So it will be pointing here.
Yes, sir.
And 1, 2, 3, 4 will be here. Now the same person 149. Tell me
yes, sir.
that let us assume that we have only one instruction here, nothing else, only one instruction.
Okay.
Okay.
Yes,
so if we return, after executing return, what will be the value of IP?
Sir, if we have one instruction, that then it should be, sir, it should be blanked, because for the first instruction our offset address should be 0, I guess. Blank.
No. Previously, our IP of this instruction, the IP of next instruction is 0012. Okay.
Yes.
Our IP of the next instruction is 0012. We have saved that thing here. It is still in the stack. Now, this particular one have only push X, nothing else. Only push X. After that, you are returning. So whenever you will be returning, IP should be reloaded, isn't it?
Yes, sir.
So what will be the value of IP then in this
So,
scenario?
in this scenario, it will be 0012. It will be returning 0012.
Okay. Okay, it is open to all. Open to all.
Yes, sir.
Sir,
88.
sir.
Yes, sir.
88. Can you answer?
Yes, sir.
Go on. Go on.
Sir, I don't think it will work because we have not redirected back to 0012. So we need to navigate back to 0012 in order for it to work.
Yes, basically I will take this answer, but what will happen? IP will get the value 1234.
Yes, sir.
Okay, but that is not our next instruction.
Yes,
So
sir. It
it
will
will
cause
go
an error.
somewhere else. Yes, I'll take that
Should
answer.
have you should
For
have first
that
of all told the
reason,
problem. You directly went to the solution that will not work. That is fine, but you
yes.
should tell why it is not working. So,
Oh,
Robil,
yes,
should I
sir.
consider that as a full answer or half answer?
Yeah. Okay, it's up to you.
Okay.
I
Sir,
think.
I don't know what will happen if there is nothing at 1234.
Exactly. You could have just said that IP will be at 1234. Whatever is there in 1234, that will happen next. So that would have been sufficient.
Yes,
Okay, you
sir.
can consider this answer.
Okay.
That is okay.
Okay. Okay.
Okay, I can consider this. You need to pop that thing to
Yes, sir.
somewhere.
Yes. We need to
So
return back
equal
to
number
one.
of push and pop should be there if you want to go back there. That is the idea that I'm trying to say. Okay.
Yes.
Sometimes this is needed because whenever you are coming from here, so maybe you have something saved in AX, something BX and CX, some important values. So at the beginning of this procedure, you can push all those value in the stack, and at the end you can pop all those value to those particular registers. And in the middle, you can write other codes of the procedure. That is the idea. Okay.
Yes, sir.
So I'm giving you another task. It is your home task, I should say. After return, there is a pop value. So try to find out what is the function of this pop value. Okay, I will add that. I will add this to your task, inshallah.
Okay, sir.
And if you cannot find, then I will explain, inshallah, in next class.
Yes, sir.
Okay, we'll start the flag register after 5 minutes, inshallah. Just after 5 minutes. We do not have much thing here. We can finish, inshallah.
Sir, one thing, when you are uploading the materials, can you upload the slide, the PPTX file? Because sometimes when you convert it to PDF, some things overlap due to the
So
animations
the
that are.
animations are overlapped. We can read it.
So if you could just upload the PPTX file, it would be better, I think.
Okay, let us consider, because we also upload the what should I say, the recording also. So that can be alternative. Let me discuss with other teachers. Okay.
Okay, sir.
Okay, we'll start at 12. Okay, 4 minutes is okay. 12:11. We'll start at 12:11.
Okay, sir. স্যার আছেন?
নেট কি আমার খারাপ?
Hello.
Yes, yes, yes.
আচ্ছা।
Sir, how are you, sir? Like, we don't see you face to face, so just talking.
Basically, the content of this lab is not much, but due to the internet connection, I think we needed much time. But it should have like the first part that we have done. It should have been completed within 1 hour.
Yes, sir.
Okay.
Initially there were some net issues, but now it is clear.
Okay. Now I think it is okay. So and the contents are easy, I think, because you only had push and pop and how the procedure works. That was our content in the last few minutes. Okay, so now we'll see the flag registers and how the flag register reflects the result. By the microprocessor, we have flag register whenever any operation is done. So that is reflected by the flag registers. So let us see how that is done. Okay, in this case, you see in the structure that we have seen in the first class, that is your flag register. So if I go inside, it is a 16-bit register, and there are status flag and control flag. So status flag, I can these are the bits. So okay, names are carry flag, parity flag. I will explain each of them. Auxiliary flag, auxiliary carry flag, then zero flag, sign flag, overflow flag, and these are the short names. Try to get this thing because obviously I will ask more question in this chapter. We have few problems, and I want to ask the questions for class performance because these are very easy. You will understand the thing. At the end, you need to answer. Okay.
Yes, sir.
So the carry flag, parity flag, auxiliary flag, these are the short names of the flags, and these are the bits of carry flag, parity flag, if you are 0 to 50. These are the
Location of
status flag, and these are the control flag. So basically we'll see the status flag. There is other chapter of control flag. We do not know whether we can cover that part or not, but basically we'll see how instruction affects the status flags. And other than this, I should say there are 6 and 3, 9. So other 6 bits has no significance. So they are of no use. Only these flags are important. Is it okay?
Yes, sir. So it is a 16-bit flag.
Yes, it is a 16-bit flag. The register is a 16-bit. So zeroth flag. Yes. Any someone is asking something. The flag register is a 16-bit register. So this is the 0th bit, and this is the 16 bit. That means if it is the first bit, there is the 16 bit. But we started with the index 0 to 15. So the 0 bit, 2, 4, 6, 7, and 11. These are pointing to carry flag, parity flag, auxiliary flag. So whenever there will be a carry, the carry flag will be 1. However, the result is 0. 0 flag will be 1. I'll explain all of them. Okay. So one example has been shown here. So let us say you're having FFFF and FFFF in AX and BX. So question, okay, not this, just try to answer it. Just you try to help me, okay? Whenever
Yes,
we'll be executing this thing, what will be the result in AX?
sir, 0.
0. That means now before executing, you see the 0 flag is 0. After executing, you can see that 0 flag becomes 1. That part after executing this particular
Yes,
line.
sir, I can see.
Okay. Now whenever you will add these two, FFFF and FFFBX, then what will happen? There will be a carry out. So we'll see all these things. There will be carry out, and the result will be 0. For this, the 0 flag is 0. And also the you'll see the sign flag. Okay, we will see each of these instructions. Just I want to show you that from this emulator you can also see the flags. So by clicking the flag, there is a button here, flag. You can see. Yes.
Sir, your voice
Yes.
was lost.
After the button, sir, we could
বাটনের
not.
পরে কেটে গেছে বলে।
Okay. Okay. I have said that there is a button of flag. If you click there, this will appear. And if you click analyze, then you will see the analysis. But if you know the analysis, there is no need of this thing. Just I have seen you have an option. Is it clear?
Yes.
Is it clear now? Okay. Now the processor uses status flag to display the result of an operation. The flag. So carry flag will be one if a carry out from the MSB, most significant bit, on addition, and if there is a borrow into MSB on subtraction. Otherwise, it will be 0. So you'll learn all the shift and rotate instruction in the next coming labs. Actually, they also affect the carry flag. Okay, you need to just try to remember on addition and subtraction if there is a carry out or a borrow into the MSB during. Then parity flag.
কথা কেটে গেছিল স্যার।
From where actually?
After borrow into the MSB. That part.
Yes. I was saying in case of addition, if there is a carry out, and in case of subtraction, if there is a borrow into MSB, these two cases carry flag will be 1. Otherwise, it will be 0. And in the next, in the upcoming labs, you will learn about shift and rotate instructions. So they also affect CF. Just this line you will see in the next in the upcoming labs. So and parity flag will be 1 if low byte of a result has an even number of 1 bits. That is called even parity. It is 0 if low byte has odd parity. There is an example, FFFFE. So if we have FFFFE, so the lower byte is FE. So if we expand this thing, what is E?
1110.
Isn't it? 110. Yes. So how many ones are here?
There are 7 ones.
7. That means it is odd parity. For odd parity, the parity flag will be 0. Are you getting me? So if the last two, if it is FFFF, the last 2 bytes, it is having 1111, then 1111. So in total we have 8 ones. That is even parity. That means your PF will be 1. As simple as it is. Is it clear?
Yes, sir.
Yes, sir.
Okay. Then the auxiliary flag. Actually, we will not cover. We do not need this thing. Whenever we'll be going to BCD operation, then we need this thing. So basically the same thing. We are interested about bit number 3, because in BCD, you know, we try to express the decimal using these hexadecimal numbers. So basically, in this case, there will be carry out or a borrow into bit number 3 on subtraction. Then your AF will be 1 or 0. So in today's class also, we will not see whether it is affecting AF or not, because our interest is basically other 5 flags. But for your idea, they carry out or borrow into bit number 3 of the result.
বিট 3 কোনটা জিজ্ঞেস করলে দেখ অনেকেই বলতে পারবে না কিন্তু রবিউল
Yes.
জিজ্ঞেস করে দেখ
আচ্ছা আমরা সামনে আগাই, শেষ করতে পারবো কিনা জানি না। Let's see.
আগা
Okay. If you are okay, just search that thing. Okay. Now 0 flag. If the result is 0, 0 flag will be 1. If the result is non-zero, 0 flag will be 0. Simple. Then sign flag. just for sign flag, you have only one thing to look into. That is the MSB. If you and your Arif sir has said several times in the last classes that if your MSB is 1, if we go for signed interpretation, your MSB 1, MSB in 1, then your sign flag is 1, and it means the result is negative. And if you are giving a signed interpretation, obviously, and sign flag will be 0 if MSB is 0. That means that is a positive number. Then about the overflow flag, we need to discuss this thing. So
Sir,
we'll
can
be
you
discussing.
repeat the AF?
Ha.
Can you repeat the AF auxiliary flag?
Okay, 134.
Yes, sir.
Can you read out what is written here? Just read out so that it can be more clear.
So AF equals 1 if there is a carry out from bit 3 on addition or a borrow into bit 3 on subtraction. AF is
Yes.
used in BCD operations.
So what do you understand?
So there is a significance of bit 3.
Yes.
Sir, I
That
think
means
Why
BC
is
the
why is
numbers
bit
grouped
3?
into 4.
So in the previous slides, you have mentioned about 3 significant portions in the 16-bit areas. So, sir, other than the insignificant portions, why only selecting bit 3? Why not the others?
No, this bit 3. This is the bit 3 of the result. So let us say you have given add ax comma bx. So there will be a result, and that will be stored in ax, isn't it?
Yes,
So
sir.
we're talking about that bit 3 of this result. Not
Sir,
the flag.
why are we taking the third bit? Because it is a
Okay,
16-bit result, it should
because
come.
it is needed in BCD.
Okay.
It is needed in.
Let me add a few things. That's why I told you that which one is actually bit 3. Do you remember your lower nibble and higher nibble? Do you remember that?
Yes, sir.
In lower nibble, how many bits are there?
4.
4 bits.
4 bit. And which is bit number 3 over there?
So from right to
From the right, we get 1, 2, 3.
That's
0.
what you start with bit 0, okay? Then bit 1, then bit 2, then bit 3. So for a lower nibble, your MSB for the lower nibble is actually your bit 3. Is it understood?
Yes, sir. In BCD, we
So
were full.
yeah, so if we go for BCD operation, the portion that Robiul said that this one is only needed for BCD operations because now we are dealing with 16 bits. So that's why we are not interested in AF. But if we ever have the chance to work with BCD, in that time you will understand what is the significance of all these things. I mean, especially for AF. Is it clear now?
Yes.
Yes.
In 4 bit, the maximum number you can write is what? 7, isn't it? So whenever you want to represent 8 and 9, you need, if you can remember BCD things from, what should I say?
Yes, sir. Yes, sir.
Yes,
DLD.
sir. DLD.
DLD, yes. So we will go for 4 bits then to represent 8 and 9. Okay. So we'll discuss the
Sir,
overflow flag.
parity bitটা আরেকবার বললে ভালো হয়,
Okay,
sir.
I have given 2 examples here. So we should, for parity bit, we need to consider. Yes.
স্যার ইভেন প্যারিটিতে আমার হচ্ছে প্যারিটি ফ্ল্যাগটা 1
Even
কখন
number
হবে?
of 1 থাকবে. Even number, there should be even number of ones in lower byte.
মানে আমার হচ্ছে রেজাল্টটাকে লোয়ার বাইটটাকে ইভেন নাম্বার অফ 1 করতে আমার প্যারিটি ফ্ল্যাগে যেটা দিতে হয় সেটা দিতে হবে, তাই তো?
না. So
Ulta
I
bolcho, ulta.
understand. Okay, let's see one example, then you will understand.
Okay, sir.
So whatever we are doing, let us say we're writing sub ax comma ax. What will be the result? Result will be 0, isn't it?
Yes, sir.
So after running this line, after executing this line, this execution will affect the flags. It will affect 0 flag. 0 flag will be 1, isn't it?
Yes, sir.
Yes, sir.
So what will be the parity flag? So as the result is 0, we consider 0 as an even number. So parity flag is also 1. So basically this instruction will affect the flags That means the result will be reflected on the flags. Note that you are giving this 1 to make that 1 or 0. This is the reflection of the result. Are you getting now?
I mean, sir, I'm asking when will be the parity flag 1 and when will be it 0?
So okay, so I have given two examples, FF. Let us say after adding something, our result is this. So we'll consider last byte. Yes, the lower byte. And another result is FFFFE. So after executing this line, let us say first of all we have this one. So it will be 1 1 1 1, then 1 1 1 1, isn't it?
Yes, sir.
So how many ones are here?
So 8 1.
8. Then even parity. PF will be 1. Are we getting now? And in this case, 1 1 1 1, 1 1 1 0. How many ones? 7. Odd. Odd parity, PF will be 0.
Sir, will the odd and even will only be considered for 1 only, not the zeros?
Yes, that's what I'm saying. You need to count the number of ones.
Then in case of the sub AX, the answer is 0, sir. So why is the parity?
So for 0, it is considered as even parity. So it is always 1. For 0, it is considered as even parity.
Okay,
that means 0 is an even number, isn't it? 0, 2, then 4, yes. All those things. So it is considered as even parity. Okay. I hope up to this you have understood, isn't it?
Yes, sir. Yes, sir.
Okay. Now let us say we are adding something here. So this is 1 1 1 and this is 1. After that you are getting this result. Now I'm just describing your overflow. Okay. So overflow can be unsigned overflow or it can be signed overflow. So in this case, what will be your carry flag? What will be your carry flag?
1.
Yes, 1. And what will be your basically, then another thing is that we need to also consider overflow flag. So so basically using the sign carry flag, we determine whether there is an unsigned overflow or not. Okay, let me come from here. So overflow there can be no overflow, there can be signed overflow, there can be unsigned overflow only, there can be both signed and unsigned overflow. So how can we determine whether it is a signed or unsigned overflow or whether there is overflow or not? So for unsigned overflow, we'll see carry flag. If carry flag is 1, that means there is unsigned overflow. And overflow flag, there is an overflow flag. That is basically if overflow flag is 1, then is signed overflow. So overflow flag only, so here it is written for unsigned interpretation. For unsigned interpretation, your carry flag is of interest, but we do not need overflow flag. For signed interpretation, if you only see overflow flag, it is enough to determine whether there is overflow or not. So has the thing been clear? Is it clear? Is it clear to all?
What is overflow again, sir? Please.
Okay, what is overflow? So overflow means okay, you can say in a word that yes, Arif, please. Arif.
Okay. There are two ways in which you can understand overflow. One by looking at the sign, which you will understand a bit later when Robil will show you the examples. I'm showing you another way, okay, of understanding the overflow.
No, Arif. His question was, what is overflow actually?
Yeah. That's what I'm saying. Okay. Yeah. How will you? I mean, what is overflow and when will overflow occur? So, your overflow will occur if suppose there is a carry in the MSB, but there is no carry out, then it will result in overflow. Or if there is no carry in but carry out, then that will also be an overflow. But if there is no, I mean, if there is both carry in and carry out at the same time, there will be no overflow. Look at the example on the left hand side. When you are adding 111 with 1, you see that in MSB there is a carry in and also a carry out. Is it understood up to this?
Yes, sir.
So since there is both carry in and carry out, so there is no overflow. That is, overflow will be 0. Now look at the right hand side. You are adding 011 with 011. So first of all, you are adding 1 plus. So first of all, you are adding 1 plus 1. You are getting 101 is being carried out. Then again 1 plus 1 plus 1. So again 1 is being carried out. But finally you are getting 1. So you see that in the MSB there is a carry in the MSB. Yeah, a 1 is coming, but there is no carry out. So in this case your overflow flag becomes 1. বুঝা গেছে কি এই পর্যন্ত?
Yes, sir.
So that is how your overflow flag is being affected. If there is both carry in and carry out at the same time, then there is no overflow. But if there is only one phenomena taking place out of these two, then there will be an overflow. Okay, and I think it will be more clear. Just keep these things for the time being. You will see around 4 to 5 or 6 examples. So in those time everything will be clear.
Okay, thing is that in a sense, in a word, you can say overflow is what you expect you are not getting that. That is in a sense you can say overflow. Like you are adding 7 with 1, the result should be 8, but you are getting 0 here. So there is a 3-bit case. So in a sense, you are saying overflow will be there when the result is not as you expected. Okay, so I'm just giving one example, and just to remember, for unsigned case our range is this for 16-bit, and for signed case our range is this. Okay, now we'll discuss about unsigned overflow and signed overflow. What Arif was discussing, that was about signed overflow. That means that then if we only, what will happen of the overflow flag? So OF is the overflow flag. That is only for signed case. So if you want to know whether there is unsigned overflow or not, that depends on carry flag. Is it clear? At the beginning of these labs, I said several times, it depends on the interpretation. Whether you are interpreting the code as signed or unsigned. If you consider that as unsigned, you need not to bother about overflow flag. If you consider as signed interpretation, then you need to know about overflow flag. So overflow flags only discusses or only reflects signed overflow. So what is signed overflow and how it is calculated, I'm just saying here. Okay, now we have 2 examples. So basically this is FF and you are adding 1 with it. So after adding all these things, you are getting 1 carry out, isn't it?
Yes, sir.
Okay, 48 you can also answer, or 115. Just give me a company. Okay.
Yes, sir.
So what is the unsigned of this, or unsigned value of this number? It is 65535, isn't it?
Yes, sir.
Okay, and what is in signed case? What is this?
So
It is
-1.
basically -1. Okay, and the lower one, it is 1 both in unsigned and signed case.
Yes, sir.
Is it okay?
স্যার
Now
বুঝি
whenever
নাই
you are,
এটা
কোনটা বোঝো নাই?
স্যার সাইনটা হচ্ছে -1
It is FFFF, yes. When you are considering unsigned interpretation, so what will be the corresponding decimal?
স্যার হিসাব করতে হবে
হিসাব করতে হবে, আমি এটা লিখে দিছি। It is the maximum number, FFFF. That is the maximum number, 65535. Yes. And if you signed case it is -1. You can calculate that.
এটা হচ্ছে 2 কমপ্লিমেন্ট করে পাওয়া যাবে।
Yes, if you just do complement, you will get -1.
Okay, sir.
Okay, So now if whenever this second number is same as unsigned and signed case. Now when you add in signed number, it is overflowing. That means it is going beyond the range, isn't it?
Yes, sir.
The result is, but the result is showing it is 0. So there is unsigned overflow, and that can be also determined by the carry flag. There is a carry, so the carry flag will be 1 in this case.
Sir,
But see, yes.
In this case, sir, there is both, sir, carry in and carry out, sir. So we should say there is no overflow.
No overflow of, I have said several times, that is overflow flag. Because there overflow flag will be 0, obviously. There is a carry in and there is a carry out. It is true. And that will affect the overflow flag. Where what I was saying, that was about signed overflow. Okay.
Okay, sir.
You will think
So-
about carry in and carry out while determining the status of overflow flag only for signed cases.
Okay,
For
sir.
unsigned cases, you don't need to worry about that. For unsigned cases, you will only look at the carry flag, nothing else.
Okay, sir.
So here, and if you just see that -1 and 1, if we add those two, you will get the result 0. So there is no overflow. We are getting the as expected result. So at the 16-bit register result, you see, you will get 0. Are you getting? So in this case, only unsigned overflow has happened, but there is no signed overflow. Is it okay?
Yes, sir.
Okay, but the second case, you can see, so we have 7FFFF, both of them same, 7FFF and 7FFF. When you add these two, so first we'll consider the unsigned case. So if you see the unsigned case, so if we convert this thing, it will be this and it will be this. And if we add, you can see this is within the range of 0 to 65535. It is within the range. And there is no carry. That means carry flag is equal to 0. That means there is no overflow for unsigned cases.
Yes, sir.
But for signed cases, what happens?
There is overflow, sir.
There is overflow because you can see this by two things. So you can see there is a carry in, but no carry out.
Yes, sir.
So the carry flag will be 1. Another thing you can say, okay, so you are adding two positive numbers because by saying the MSP, what do you see?
Both are positive.
MSP. These two are positive, but you are getting negative. Are you getting? That means when two positive numbers are added, so there can be many combinations. Let us say your two positive numbers are added and you are getting the result negative. That means there will be overflow. You are adding two negative numbers. Two negative numbers. In this case, the result should be negative. But if you get positive, then there will be overflow. But in this case, when there are two different cases, like you have a and B, A is positive, B is negative, and you are subtracting that thing. So there will be no overflow in this case because both of them are within the range. So in one example, I'll show this thing. So basically, the sign that you expect, if you do not get that sign, then there will be overflow. There is another interpretation you can do like this. So I'm talking about, obviously, I'm talking about signed overflow. That means OF, how that OF is determining. So we'll see a few examples, then things will be more clear, I hope. Now one table has been shown here that which instruction affects which flags. So move and exchange does not affect any flag. Add and subtract affects all the flag. Increase, decrease, except CF, it affects all. Negative. So CF is 1 unless the result is 0 and OF is 1 if the result is this. In case of 16-bit. So we'll see this example. Whenever we'll see the example, these things will be more clear. So let us see the first example. So obviously I will ask 115. let me start with him. So tell me, what will be the values of these flags and why?
Robil, will it be counted as class performance?
No, first one let
Okay,
me
okay, okay,
discuss.
okay,
So
okay, okay.
115.
Yes, sir.
What will be the sign flag? So you
Sir,
are
the
okay. Let me explain. You are adding AX and BX.
okay, sir.
X is having FFFF and BX is having FFFF. You are adding those two. After addition, the result will be in AX, isn't it? Because AX is AX plus BX.
Yes, sir.
So in the result is this one. Now tell me, what will be these flags? 1001. What will be this one and why? Sign flag. First of all, sign flag. What will be the sign flag?
The sign flag should be 0 as it is positive number.
Is it positive number?
Uh,
How do we determine whether that is a positive or negative?
Sir, is it signed interpretation or unsigned interpretation?
Okay,
ইন্টারপ্রিটেশন যাই হোক সাইন ফ্ল্যাগের জন্য তো তুমি শুধু এমএসবি দেখবা, তোমার তো আর কিছু দেখার দরকার নাই তো এখানে, তুমি জাস্ট এমএসবি দেখো এমএসবি কি।
আচ্ছা 1 স্যার, তাহলে হচ্ছে সাইন ফ্ল্যাগ হচ্ছে 1 হবে।
And another thing is that the microprocessor does not understand whether you are using signed interpretation or unsigned interpretation. It gives you the result of everything. How you are interpreting that thing, that is up to you. It has been covered in lab 2, I hope. So whenever the MSB is 1, your sign flag will be 1. Is it clear?
Yes, sir.
If your MSB is 0, your sign flag will be 0. That is the idea. Okay. Now what
Okay,
will
sir.
be the 0 flag?
Sir, 0.
Because
It's not 0. The answer is not 0.
okay. What will be the parity flag?
So parity flag, there is 7 1 or odd number of 1, so there will be, I guess, sir, I forgot.
Okay. For odd parity it is 0.
Okay, sir.
Then carry flag?
So there is a carry 1 in the result.
So what will be the carry flag?
So 1.
Okay. And then overflow flag?
Sir, I'm not sure about the overflow flag.
Okay, that's what I'm saying. I will explain this in 2 interpretation. So see, what is this number, positive or negative?
So it's a positive number.
So how do you know this
negative number.
this is positive?
Oh, I don't know, sir. It can be negative if it is sign interpretation.
Okay, I'll move to 88. Are you here? 88.
Yes, sir.
Can you tell me whether it is positive or negative?
Sir, negative because MSB is 1.
1, isn't it? Yes. So it is negative. So what is this one? Positive or negative?
Negative.
Yes. And you are adding 2 negative numbers. And what is the result you are getting in AX? Positive or negative?
Negative.
Negative.
So as expected, isn't it? So you are adding 2 negative numbers. That should be a negative, isn't it?
Yes, sir.
That means your result is as expected. So you can say the overflow flag is 1. Another sense, there is a carry in and carry out in the MSB. So if
ওভারফ্লো
there is
জিরো,
carry
রবিল
in and
ওভারফ্লো
carry
জিরো
out,
তো অ্যাজ এক্সপেক্টেড হলে
oh sorry
ওভারফ্লো
sorry
জিরো
sorry 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 sorry. So as expected, that means my negative when you add negative and negative, then your result is negative. So the overflow flag is 0 because you are getting the result as expected. And another sense, there is a carry in and carry out. That means there will be no overflow. The signed overflow, there will be no signed overflow. So wave is determining whether there is a signed overflow or not. Is it clear?
Sir, what do you mean by as expected? What is the expected here?
Okay, you are adding -7 and -7. What do you expect? What will be the value? -14, isn't it?
Yes, sir.
So in the previous case, here you are adding two positive numbers. You are, let us say, adding 7 and 7, and you are getting -2. So is it possible?
No, sir. No, sir.
So that is the thing. Whenever in this case there is a signed overflow, in case the overflow is 1, so you are adding two positive number, but you are getting the result as negative. Are you getting? Are you getting?
Yes, sir.
For signed interpretation, I am saying about the signed
Sir, I got it,
interpretation.
sir. I got it.
Sir, I have a question.
Yes.
Sir,
Yes.
in some
Yes.
earlier,
I cannot hear you.
Sir, can you hear me, sir?
Yes. Now.
Sir, sometimes earlier you said that if we subtract a number like a minus b, it will be well within the range of 16-bit range. Sir,
Yes.
sometimes can this happen that if you subtract, it will be on the range if there is some sign interpretation?
Rubil, can I answer?
Yes.
I think I got your question.
Yes,
So see, whenever there are opposite signs, so say a minus b. So whenever you are performing a minus b, definitely you are storing the two values in some register, right?
yes, sir.
Whatever answer you will get, the answer has to be smaller than the negative number you have already considered. See, a minus b.
Yes.
So what does that mean? You can say that I am adding something with a negative number. Can I say that?
Yes, sir.
Can I say that?
Yes, sir.
So that means the answer will definitely be a smaller negative number than the one you considered. There is another way. You can say that I am subtracting a negative number from a positive number. So the answer you get will definitely be smaller than the positive number you have considered, right?
Yes, sir.
So see, in either way, you are already storing the largest positive or negative number in some register, and the result you are getting has to be either smaller than the most positive number or smaller than the most negative number. So it has to be, I mean, it will automatically be able to adjust in some register, so there can never be an overflow. Did you get the answer?
Yes, sir. But it doesn't it depend on the first higher negative number we are guessing?
Guess what is the maximum negative number that you can have? Tell me.
Sir, on
Let us say 128.
Yeah, that is the highest negative number you can have, right? Minus 128. So now you will add something with this number. So can the result be beyond minus 128? Can you ever get minus 129 after adding?
Positive, no, sir. No.
Impossible,
And
right?
most positive is 127.
Yeah, and the most positive is 127. Now you subtract something from 127. So can you ever get 128?
No, sir.
So that's the explanation.
Yes, sir.
Okay, Arif, can you get this one? Arif.
Bol.
But actually, can you ask someone?
Okay,
we'll
yeah.
discuss one or two.
Yeah, we should ask ID 141. Okay, question kora hoy nai kohono.
141.
141, are you there, Samadul? এর আগের দিনও ওকে একবার ডাকছিলাম, অ্যাবসেন্ট ছিল। আজকেও কি অ্যাবসেন্ট রবিউল?
কত আবার বলতো?
141 সামাদুল, আইডি 141।
নাই ও নাই।
আচ্ছা, তাহলে আজকেও অ্যাবসেন্ট। 145 তৌফিক জিজ্ঞেস কর।
Yes, you give the answer of the sign, these flags, and also why. Try to interpret why. We are adding AL and BL. AL is this one and BL is this one. After doing the addition, AL is having this value. So what will be the flag? How the flag will be affected?
Sir, I missed some part of the lecture, so I can't answer.
Okay.
Can I try, sir?
Arif.
Sir, I also want
34, sir. I haven't answered any previous one, sir.
কত আইডি কত?
34.
I also want to try.
34. Yeah, today I have given you a chance. Another day I asked you, you are absent. Yeah, you have not got any right answer that you can say. So Robiul, I think you can give the chance to 34.
Okay, 34.
Sir, since we see that at the last we get AL value 0, 0, 0, 0, all everything is 0, so the sign flag will be 0 here.
So what is the reason of this 0?
So because at the end of the answer we see that the value of AL everything is 0, sir. The first bit MSB is not 1.
So,
because of the MSB
yes, because of MSB. Okay, then
sir, second we get the 0 flag, sir. Here the 0 flag
Yes.
will be 0 flag, 0 flag. It will be 1, sir.
Why?
Sir, it is 0 হওয়া উচিত না।
Yes, sir. It should be 0.
Sir, I'm sorry, sir. It will be 0, sir, because there is no output value of.
You are saying the 0 flag is 0 or 1?
34 ঠিকভাবে আনসার দাও তুমি, এটা কিন্তু তোমার সেকেন্ড চান্স আজকের ক্লাসের। 0 ফ্ল্যাগ কি হবে?
Okay, then parity flag.
Sir, parity flag টা পারবো, স্যার।
বলো parity flag।
স্যার 1 পারো বলো। Parity flag 1 হবে, স্যার, because আমার ক্লাসে সব স্যার আমরা জানি স্যার যদি স্যার ইভেন বিট অফ থাকে স্যার তাহলে ইভেন প্যারিটি, আর যদি অড থাকে তাহলে অড প্যারিটি, স্যার।
এখানে ইভেন কিভাবে হলো?
স্যার এখানে যেহেতু সবকটা 0, স্যার, আপনি বলছেন সবকটা যদি 0 হয় তখন আমরা 1 করব, স্যার।
আচ্ছা, that means 0 is even, they consider 0 as an even number, that means it is an even parity. Okay, then carry flag.
স্যার এখানে স্যার ক্যারি ফ্ল্যাগ আমরা 80 + 80 এক করে দেখি, স্যার ওইখানে 1 আসছে, স্যার, সো ক্যারি ফ্ল্যাগের এখানে 1 হবে, স্যার।
Then overflow flag.
স্যার ওভারফ্লো ফ্ল্যাগ আমরা দুইটা পজিটিভ যোগ করতেছি, স্যার, লাস্টে দেখতেছি আমাদের 1 ওইটাতে সাইন রাখতেছি, স্যার, সো আমাদের এখানে ওভারফ্লো ফ্ল্যাগ 1 হবে, স্যার, কারণ আমরা পজিটিভ যোগ করতেছি আর অ্যানসারে স্যার যদি
Okay, just tell me, this is positive, these two are positive, isn't it?
Yes, sir.
Okay, so Arif, can we go for another one? Zero flag and overflow
I
flag?
think we should go for 91. Kais,
are you there? We're at the end actually.
91 Kais nai?
Yes, sir.
Can you answer about the zero flag and overflow flag?
Sorry, sir.
Sir, I want to answer, sir. 48.
No, 48 today we gave you a chance, not today. Let's go to 98.
Yes, sir.
Answer korte parba?
Sir, 0 flag will be 1 as the result is 0, and overflow bit will be 0.
Overflow 0. Why?
Sir, CF is 1, so it should be overflow should be 0.
রবিউল, ওভারফ্লো যদি না পারে আমি এটা আনসার কনসিডার করতেছি না, ঠিক আছে? ওভারফ্লোর উপরে পুরো মার্কস করতেছি আমি।
ওকে, ওপেন করে দাও আরিফ।
হ্যাঁ, নাও ইট শুড বি ওপেন।
স্যার আমি একটা কনফিউশন ক্লিয়ার করে আমি 34, স্যার, এমনি জিজ্ঞেস করছিলাম, স্যার।
একটু পরে করো, আমি কোশ্চেনটা শেষ করি।
আগে এটা কোশ্চেন শেষ হোক। হু ক্যান আনসার হোয়াট উইল বি দ্য ওভারফ্লো?
Yes, sir.
আইডি কত?
Sir.
আইডি বলো, আইডি
বলো।
134.
134 134 না, 149 149 স্যার। আর কেউ আছে? 134 149 এই দুজন স্যার, আর কেউ আছে?
48.
88 ও বাদ 48। রবিউল, যারা আনসার করে ওরাই ঘুরে ফিরে আনসার করে।
দে ওদেরকে চান্স।
দাঁড়া, কে 48 বললো লাস্টে নাকি?
Yes, sir.
আচ্ছা 48 বলো, দেখি 48 বলো।
Sir, overflow would be, sir, 0, sir.
Why 0?
Sir, because there is both carry in and carry out, sir, and this is a sign interpretation, sir, so it would be 0, sir.
না।
Sir, can I try again? 98.
98? হ্যাঁ বলো।
Sir, OF will be 1. Sir, আমাদের রেজাল্ট এক্সপেক্টেড সাইন যেটা সেটা আমাদের আসে নাই, দুইটা নেগেটিভ অ্যাড করছি, সো এন্ড অ্যানসার হচ্ছে পজিটিভ আসছে, সো
ওকে, নাও আই উইল টেক দ্য আনসার।
স্যার আই সেড দ্য এক্সাক্ট সেম থিং, স্যার।
কে আইডি কত?
34, স্যার।
না, তুমি এক্সাক্ট সেম থিং বলো না।
স্যার আমি যেটা বলেছিলাম, স্যার, আমি বলেছিলাম, স্যার, আমরা প্লাস 80 আর ওইটা প্লাস, তাহলে আলটিমেটলি আমাদের রেজাল্টে যেটা মাইনাস আছে, স্যার, বিকজ 100 টা এমএসবি 1, স্যার, সো এটা যেহেতু মাইনাস কনসিডার করতেছি।
MSB is not 1. MSB is not 1.
That is not
you
your
are saying
MSB.
these two are positive and you are saying this is negative, but thing is that these two are negative and your result is 0.
Yes,
your result is not a negative number. Are you getting me?
Yes, sir. Yes, sir.
So you are adding 2 negative and you are getting the result 0. So the result is not as expected.
Yes, sir.
And another thing you have said about carry. You have said about carry. So all this thing will be 0 up to here. So there is only carry out. You see, there is only carry out, no carry in.
Yes, sir. Yes, sir.
Okay.
কার জন্য কি কোশ্চেন ছিল রবিউল?
স্যার এখানে
এটা
জিরো
98,
জিরো ফ্ল্যাগটা কি জিরো
98%.
হবে না?
না না, zero flag will be 1 when the result is 0.
Yes, sir.
বাট স্যার এখানে তো আমাদের রেজাল্টটা জিরো আসার কথা না, বাট
Why the result will not? You are adding al plus al equal to al plus el. So this is 1 0 0 0 0, then 0 0 0 0. That means what? L can hold up to 8. That's your carry.
yes sir.
So I have already written the result is 0. Are you getting me? So what L can have, that is your result, isn't it?
Yes sir.
So what is L?
You are getting a result of 9 bit, but the maximum you can hold is 8 bit. So definitely you will get, I mean, your result will be based on whatever you can hold.
বুঝছো 15?
স্যার ক্লিয়ার না এখনো, দেখতে হবে একটু পরে।
ওকে, একটু দেখো। এল এ তুমি ম্যাক্সিমাম কয়টা ভ্যালু রাখতে পারবা? হাউ মেনি বিটস ইজ এল অফ?
8 বিটস।
8 বিট। তো তোমার রেজাল্টটা আসছে 9 বিট। তো ও 9 বিট 8 বিটের মধ্যে রাখবে কেমনে বলো?
আচ্ছা, আমরা শুধুমাত্র 8টা বিটের ভিতরে যদি 0 থাকে, মানে 0 হয়, তখন আমাদের হচ্ছে 0 ফ্ল্যাগটা 1 হবে।
হ্যাঁ, if it is 16 bit then all the 16 bit should be 0.
মানে you are only interested,
you are considered about the register. Yes.
You are only interested in the register where you are storing your result. If the register is 8 bit, then you will only see the first 8 bit and that will be your result. If the register is 16 bit, doesn't matter whether your answer is 17 bit or not, you will be only interested in the first 16 bit and that will give you your answer.
Okay sir.
Okay, last question to note this one. You do these things by yourself. I think now you can do by yourself. Just I'll explain the overflow flag here. So the first one is negative, and also this one is negative, but you're getting this one is negative in a sense there is a negative sign. Like if you are doing something like this, A is by default negative by the first MSB, and you are putting a negative sign and giving B. So basically you are adding 2 negative numbers, but you are getting a positive number. So overflow flag will be 1. Okay, you do this by yourself. Okay, now tell me, Arif, একটা ID last
I think we should ask 179. We have never asked him. 179. Abder Rahman, are you there?
179.
আছে? 179 মোস্টলি নাই। 155 আছে রবিউল?
হ্যাঁ আছে তো, দেখতেছি।
তাহলে 155 কে জিজ্ঞেস কর।
155.
Yes sir.
What will be the flag? How it will affect the flags?
Sorry sir.
Okay, let's make it open. Let's make it open.
First tell me the ID. Who can answer? Okay, tell me your ID.
Sir, can I try?
Sir, যারা বলছি তারা
হ্যাঁ যে কেউ
ID বলো, I will allow. Tell me the ID.
134.
134. আর কেউ আছে 134 ছাড়া?
Sir, 149.
149. Okay, 149 answer.
Okay sir. Sir, here the sign flag will be as it is 1. So the sign MSB is 1, so sign flag.
Okay, 149.
Yes sir.
লেখ না রবিউল, আনসারগুলো লেখ না, আনসারগুলো লেখ না।
আচ্ছা,
যেটা বলে লেখ, এখন কিছু বলিস না। হ্যাঁ, ওকে।
Okay, so 0 flag, as there is it is not, the answer is not 0, so it will be 0. And the parity flag, I can see the lower bits are there are 7 ones, so it will be 0. So sorry sir, it will be 1. Sir,
No, it will be 0 actually.
Sir, for odd cases,
For
it will
odd
be,
parity, the odd
okay,
parity
sir. Odd
flag will be
parity,
0.
it will be 0.
Yes.
For carry, so there is as it is, as we are moving, sir, there is no carry, I guess.
Okay,
it
so what will
0.
be? Okay.
It is -5. As it is MSB is 1, so there is no overflow as we expected result. So it will
Sir,
be 0.
can I answer?
কত আইডি কত?
Sir, 115.
115 ওকে আনসার।
Sir, there will be no change in the flags. It will remain as it was previously.
Exactly.
So there were instructions move and exchange. Actually, we for these two we are just moving the things. That does not affect the flags. Okay.
Yes sir.
Okay.
আগে কি আনসার করছিলা, বুঝছো এখন কি?
বুঝতে পারছি স্যার। জি স্যার, মানে অ্যাড বা সাবট্রাক্ট করলে স্যার তখন হচ্ছে
add subtract neg
এগুলি করে,
find this one. Yeah.
এগুলি করে, ঠিক আছে।
So here also
স্যার
if you want to
একটা জিনিস স্যার একটু আস্ক করতে পারি স্যার, প্রিভিয়াসলি ডিসকাস স্যার। স্যার আরিফ স্যার একটা জায়গায় বলছিলেন স্যার যে যখন ক্যারি ইন বা ক্যারি আউট থাকবে তখন হচ্ছে থাকবে না, তখন হচ্ছে ওভারফ্লো হবে। এই জিনিসটা স্যার একটু যদি এক্সপ্লেইন করতেন, মানে সাইন কেস স্যার।
ওকে 149 আই জাস্ট ওয়েট আরিফ, আমরা মনে হয় ক্লাসটা শেষ করি।
হ্যাঁ, ক্লাসটা শেষ কর, কারো কোনো কনফিউশন থাকলে মানে এই জিনিসটা হয়তো আরেকবার এক্সপ্লেইন করা হবে না, কারণ অলরেডি সময় নাই বেশি। তুই শেষ কর আগে, ও টাইম পার হয়ে গেছে।
হ্যাঁ। সো আই উইল টেক দ্য অ্যাটেন্ডেন্স। আচ্ছা, অ্যাটেন্ডেন্স আমি আজকেরটা ইয়া থেকে নিব। আচ্ছা, লেট মি টেক এ স্ক্রিনশট, জাস্ট ওয়েট।
সিআর কি আছে?
নো স্যার, সিআর আমাকে মেইল দিছিল, ও সম্ভবত থাকতে পারবে।
আচ্ছা, 141 কে কিন্তু একদিনও পাইলাম না, ওকে 2 দিন ডাকছিলাম, ও কিন্তু একদিনও রেসপন্ড করে নাই। ও কি নাই নাকি?
স্যার আমাদের এই যে ইয়েগুলা যেমন হচ্ছে 21H যেই কমান্ডটা ইন্টারাপশন, এগুলার যেই ভ্যালুগুলা ছিল যেগুলা দিলে আমাদের বিভিন্ন কাজ হয়, ভ্যালুগুলা কি সব মুখস্থ রাখতে হবে?
সবগুলো লাগে না, তোমরা এখানে যে
আমরা তিনটা বা চারটাই তো লাগতেছে, এই চারটাই তো মনে রাখতে হবে।
চারটা লাগতেছে মোটামুটি, 1 2 9 আর হচ্ছে 4CH, মোটামুটি এই কয়েকটা জানলে তোমার এখানে হয়ে যায় আর কি। মানে শোনো, আমাদের এই কোর্সটার মেইন টার্গেট হচ্ছে আমরা তোমাদেরকে অ্যাকচুয়ালি জাস্ট একটা বেসিক আইডিয়া দিয়ে যাব, যাতে লাইক ফিউচারে যদি কেউ এই লাইনে আসতে চাও বা এই জিনিসগুলি নিয়ে কাজ করতে চাও, তখন যাতে তুমি ধরো 1 2 9 4CH ছাড়াও যদি অন্য জিনিসটা দেখো, তুমি বুঝবা যে কিভাবে কাজ হচ্ছে। বুঝা গেছে? মানে মেইনলি আমাদের টার্গেট হচ্ছে জাস্ট আইডিয়া দাও, এই জন্য এটাকে কিন্তু জাস্ট একটা ল্যাব আকারে রাখা, নট ইভেন আ থিওরি, বাট অ্যাকচুয়ালি ইট শুড হ্যাভ বিন আ থিওরি কোর্স।
There are so many content actually we could not cover actually, obviously.
দেখো তোমাদের
Okay, for I have taken the attendance. I think if you do not have any question you can leave. And 149 you can stay, you have asked something, but if you do not have a question you can leave. Okay,
একটা ছোট কোশ্চেন ছিল।
আচ্ছা, একটা করে আসি। 149 আরিফ, ওইটা একটু বল।
আমার লিখতে পারলে ভালো হইতো রে, তুই ওই স্লাইডটায় যা যেখানে শুধু ওই যে সাইন্ড ওভারফ্লো আনসাইন্ড ওভারফ্লো আছে না, ওইখানে যা। আমার তো লেখার ইয়ে নিয়ে বসি না। হ্যাঁ, এইখান থেকে তো বোঝা যায় জিনিসটা। আচ্ছা
এইখানে, হ্যাঁ আচ্ছা 149
আমি এখানে দেখাই আচ্ছা 149 কোনো ফরেনার নাই তো না?
একজন আছে স্যার।
আছে
কে? আব্দুর রহমান
179
179 ওরে কোশ্চেন করলে ও রেসপন্ড করে না, আবার এখানে বসে কি করে?
ওকে বল বাংলায় বল। আর ইউ দেয়ার 179? আর ইউ দেয়ার? ওকে বাংলায় বল আরিফ।
আচ্ছা মশুর, আমরা ওভারফ্লো চিন্তা করব শুধুমাত্র সাইন্ডের ক্ষেত্রে, ঠিক আছে? আনসাইন্ডের ক্ষেত্রে আমরা চিন্তা করব না।
আচ্ছা সাইন্ড ওভারফ্লো এটা বলে দে। সাইন্ড
হ্যাঁ মানে ওভারফ্লো ফ্ল্যাগ যখন আমি বলছি, আমি শুধুমাত্র চিন্তা করব যে সাইন্ড সেন্সে ওভারফ্লো হচ্ছে কিনা, আর কিছু চিন্তা করব না, ঠিক আছে? আর আচ্ছা ক্যারি ইন ক্যারি আউটের যে বিষয়টা ছিল সেটা হচ্ছে, তুমি উপরের যে এক্সাম্পলটা আছে, প্রথমে উপরের এক্সাম্পলটা দেখো। হ্যাঁ, যেখানে হচ্ছে এফ 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 এই নাম্বারটার সাথে তুমি 1 অ্যাড করছো, ঠিক আছে? তুমি একটা জিনিস দেখো, তুমি যখন একদম তোমার রাইট হ্যান্ড সাইডে 1 আর 1 অ্যাড করলা, তোমার কি একটা 0 আসলো, তাহলে কি একটা ক্যারি গেল না এখানে? এইভাবে পরেরটা কি আবার 1 1 অ্যাড হয়ে 0 হয়ে কি আরেকটা ক্যারি গেল, রাইট?
ইয়েস স্যার।
এইভাবে যদি তুমি যেতে থাকো একদম এমএসবি এর আগে আবার 1 1 0 হয়ে একটা ক্যারি গেল, তাহলে এই যে ক্যারি আসলো এটাকে আমরা বলতেছি যে একটা ক্যারি ইন আসছে এমএসবি তে, ঠিক আছে? এটাকে আমরা বলতেছি একটা ক্যারি ইন আসছে। এরপরে দেখো তুমি আবার 1 1 করে কি 1 0 পাইলা না আনসার?
জি স্যার।
তাহলে কি এমএসবি থেকে একটা ক্যারি আউট হইছে না?
হ্যাঁ স্যার।
এই যে ক্যারি ইন আর ক্যারি আউট যদি কখনো একসাথে হয় তখন তোমার ওভারফ্লো ফ্ল্যাগ 1 হয়, বা আমরা বলি যে সাইন্ড সেন্সে ওভারফ্লো হইছে। সরি উল্টা বলতেছি, ওভারফ্লো ফ্ল্যাগ 0 হয়, আমরা বলি সাইন্ড সেন্সে ওভারফ্লো হয় নাই যদি ক্যারি ইন এবং ক্যারি আউট একসাথে হয়, ঠিক আছে? নিচের এক্সাম্পলে দেখো তোমার ক্যারি ইন আসছে, তুমি এমএসবি এর আগের অংশটা দেখো 1 + 1 অ্যাড করছো, আগে একটা ক্যারি ছিল, সো 0 1 হয়ে এখানে 1 আসছে, বাট একটা ক্যারি ইন আসছে, রাইট?
হ্যাঁ স্যার।
এখন দেখো এই ক্যারি ইন থেকে কি তুমি কোনো ক্যারি আউট পাইছো?
না স্যার।
তুমি কিন্তু কোনো ক্যারি আউট পাও নাই, বাট তোমার এমএসবি তে একটা ক্যারি ইন আসছে। সো যেহেতু ক্যারি ইন আছে আমার ক্যারি আউট নাই, সেই জন্য আমার ওভারফ্লো ফ্ল্যাগ 1 আর কি, মানে আমরা বলি যে সাইন সেন্সে ওভারফ্লো হইছে।
ইয়েস স্যার।
বুঝা গেছে? সো যদি কখনো ক্যারি ইন এবং ক্যারি আউট একসাথে হয়, সাইন সেন্সে কোনো ওভারফ্লো হয় নাই এবং ওভারফ্লো 0। আর যদি ক্যারি ইন ক্যারি আউটের মধ্যে যে কোনো একটা ঘটে, তাহলে আমরা বলি সাইন সেন্সে ওভারফ্লো হইছে এন্ড ওভারফ্লো ইজ ইকুয়াল টু 1।
স্যার আমি এখানে একটু যদি
আই ওয়াজ আস্কিং অ্যাবাউট স্যার, মানে কোনোটাই যদি না হয়, মানে আপনি একটা কেস বলছিলেন যে ক্যারি ইন ক্যারি আউট যদি না থাকে,
কোনোটাই হয় নাই,
হ্যাঁ
না তাহলে ওভারফ্লো নাই। যদি ক্যারি ইনও হয় নাই ক্যারি আউটও হয় নাই, তাহলে ওভারফ্লো নাই।
Can you explain that same thing in the 8080 case, sir? যে একটা एग्जांपल দেখেন।
যা রবিল যা তো 8080 তে
এটা আমি একটু হচ্ছে
দাঁড়া একটা করে আসি। আচ্ছা 8080, ঠিক আছে? তুমি 80 এর বাইনারি কি হবে? 80 এর বাইনারি হচ্ছে, ধরো এটা তো 8 বিট নিয়ে কাজ করতেছে, হ্যাঁ 100, তারপর হচ্ছে আবার 4টা 0, ঠিক আছে? হ্যাঁ আবার পরেরটাও হ্যাঁ সেম জিনিস। এখন তুমি অ্যাড করো, রবিল লিখতো অ্যাড করে লিখছো, এখন তুমি অ্যাড করো, দেখো এমএসবি তে কি তোমার কোনো ক্যারি আসছে? ক্যারি ইন হইছে কোনো?
ও স্যার এখানে ক্যারি আউট হইছে স্যার শুধু।
এক্স্যাক্টলি, শুধু ক্যারি আউট হইছে। তাহলে ক্যারি ইন এবং ক্যারি আউটের মধ্যে যে কোনো একটা যদি শুধু ঘটে, তাহলে আমরা কি বলি? সাইন সেন্সে ওভারফ্লো হইছে, সেই জন্য ওভারফ্লো ফ্ল্যাগ হচ্ছে 1।
ওভারফ্লো 1।
আচ্ছা এরপর নেক্সট কোশ্চেন বলো।
এইটা হচ্ছে যদি এভাবে ইন্টারপ্রেট করি যে প্রথমটা যেহেতু এমএসবি 1, সো এটা নেগেটিভ একটা নাম্বার, পরেরটাও সেম, সো দুইটা নেগেটিভ নাম্বার আমি অ্যাড করতেছি, সো আমার আনসার নেগেটিভ আসার কথা ছিল, বাট এমএসবি তে আমার 0 আসছে, সো
এক্স্যাক্টলি হ্যাঁ, টোটাল দুইটা ইন্টারপ্রিটেশন আছে। তুমি আইদার ক্যারি ইন ক্যারি আউট দিয়ে চিন্তা করতে পারো, অথবা তুমি শুধু এমএসবি দেখে সাইন দিয়েও চিন্তা করতে পারো, যে কোনো একটা করো, যে কোনো একটা দিয়েই, মানে যেটা দিয়ে তুমি করো না কেন তুমি সেম রেজাল্টে পৌঁছাবা। বাট জিনিসটা বোঝার তোমার দুইটা উপায় আছে, দুইটা ইন্টারপ্রিটেশন। একটা হচ্ছে সাইন দিয়ে ইন্টারপ্রেট করা, আর একটা হচ্ছে ক্যারি ইন ক্যারি আউট দিয়ে ইন্টারপ্রেট করা। সেটা তোমার চয়েস, তুমি কোনটা দিয়ে করবা।
তবে আমার তো এটা অবশ্যই বিসিডি সিস্টেমে করা লাগবে স্যার।
যদি ক্যারি ইন ক্যারি আউট করো তাহলে তোমার বাইনারি সিস্টেমে করতে হবে।
আর স্যার আরেকটা কোশ্চেন হচ্ছে 0 ফ্ল্যাগের ক্ষেত্রে আমার যে 8 বিটের টোটালটা 0 হইলে জাস্ট আমার 0 ফ্ল্যাগ 1 হবে, বাকি সব ক্ষেত্রে 0 ফ্ল্যাগ 0 হবে।
হ্যাঁ যদি তুমি 8 বিট রেজিস্টার নিয়ে কাজ করো, মানে শুধু মনে করো এল বিএল সিএল ডিএল অথবা এইচ বিএইচ সিএইচ ডিএইচ, যদি এএক্স
দিলে কিন্তু 16 বিট,
হ্যাঁ এক্স বিএক্স সিএক্স ডিএক্স নিয়ে কাজ করো, তখন কিন্তু তোমার 16 বিট চিন্তা করতে হবে।
জি স্যার, মানে হচ্ছে আমি যেটুকু নিয়ে কাজ করব শুধু ওইটুকুর আনসার যদি আমার লাস্টে 0 আসে তখন আমার হচ্ছে 0 ফ্ল্যাগ 0 0 1 হবে, আর 0 না আসলে হচ্ছে 0 হবে, 0 ফ্ল্যাগ।
হ্যাঁ হ্যাঁ হ্যাঁ
ওকে।
শুধু লাস্ট ব্যাপারটা হলো যে রেজাল্ট যেটা স্টোর হবে এখানে ফাইনালি, তুমি যেখানে রেজাল্টটা পাইলে এখানকার রেজাল্ট কোন অ্যাড এর রেজাল্ট কই থাকবে? এএল এ থাকবে।
জি স্যার।
এএল এ কি আছে জাস্ট এইটা দেখবা। এখন এএল এ তো ম্যাক্সিমাম 8 থাকতে পারে, 8টা বিট থাকতে পারে, ওইভাবে চিন্তা করো, বুঝতে পারছো?
জি
স্যার
স্যার।
আরেকটা কোশ্চেন কি করা যাবে স্যার?
হ্যাঁ
হ্যাঁ হ্যাঁ করো করো, সমস্যা
স্যার
নেই।
ওই ক্যারি ইন ক্যারি আউট ছাড়া যে আপনি আরেকটা ইন্টারপ্রিটেশন বললেন স্যার, ওটা যদি একটু সংক্ষেপে আপনি বলতেন।
এটা বুঝছো? আমি এটা এইটারটা বুঝছো কি হইছে?
জি
দুইটা
স্যার।
নেগেটিভ অ্যাড করছো, 0 পাইছো।
জি।
হ্যাঁ
এটা
আচ্ছা,
রবিউল,
let's
রবিউল
go here.
এই
হ্যাঁ
আমি বের হয়ে যাই, আমার আবার দুইটাই ক্লাস আছে, ঠিক আছে?
আচ্ছা ঠিক আছে, বেরো বেরো। হ্যাঁ।
ওকে ঠিক আছে, ওকে।
আচ্ছা এখানে দেখো তোমার প্রথমটা কি নেগেটিভ,
জি।
পরেরটা পজিটিভ, তুমি তো করতেছো, তার মানে ওইটাও নেগেটিভ, মানে অ্যাজ ইফ দুইটা নেগেটিভ নাম্বার তুমি যোগ করতেছো, তাই না?
জি।
তো দুইটা নেগেটিভ নাম্বার যোগ করলে কি পাওয়ার কথা?
নেগেটিভ পেয়েছি।
নেগেটিভ, কিন্তু এমএসবি
এটা তো স্যার পজিটিভ স্যার।
হ্যাঁ, তার মানে এখানে ওভারফ্লো হবে। এই দেখো ওভারফ্লো উইল বি 1।
ওকে স্যার।
বুঝছো?
আর এই ক্ষেত্রে স্যার
এটার ক্ষেত্রে
ব্যাপারটা কি খেয়াল রাখবো স্যার, যদি এটা 8 বিটের ক্ষেত্রে এরকম হয় স্যার, মানে তখন
কয় বিট কয় বিট?
স্যার 8 বিটের ক্ষেত্রে যদি রেজিস্টার গুলো চিন্তা করি তখন তো স্যার ওই
হ্যাঁ 8 বিটের ক্ষেত্রে এই যে এটাও তো 8 বিটের ক্ষেত্রে করলাম তো, 8 বিটের ক্ষেত্রে তো এখানে করলাম তো,
স্যার বুঝতে পারছি স্যার।
বুঝছো? 8 বিটের ক্ষেত্রে হ্যাঁ 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 8 বিটের ক্ষেত্রে তোমার 8টা বিট নিয়ে চিন্তা করবা, 8টা বিটের মধ্যে এমএসবি কোনটা, আর 16 বিটের ক্ষেত্রে এই 16টা বিটের মধ্যে এমএসবি কোনটা সেটা। এখানে যখন করবা প্রথমটা কি নেগেটিভ, পরেরটা কি পজিটিভ, দুইটা ভিন্ন সাইন তুমি অ্যাড করতেছো, তার মানে এটা সব সময় ওভারফ্লো এটার 0 হবে, কারণ এখানে ওভারফ্লো হওয়ার চান্সই নাই।
পরেরটা পজিটিভ স্যার, পরেরটা মানে যোগ করার জন্য পজিটিভ ধরছি নাকি স্যার?
না না না, যোগ করেন না, এটা তুমি 0 1, দ্যাট মিন্স এটা আসলে 0 1 মানে কি 0 0 0 0 এন্ড 0 0 0 1, তার মানে এর এমএসবি কত
স্যার? 0 স্যার।
0, দ্যাট মিন্স এটা পজিটিভ।
সরি স্যার, পজিটিভ স্যার।
আর এই সেম জিনিস মুভের ক্ষেত্রে হবে না, নেগেটিভের ক্ষেত্রে এখানে দেখো তুমি এইটা একটা নেগেটিভ, কারণ হলো 8 এর শুরুর কি 8 0 0 দেন সবগুলো 0, এটা একটা নেগেটিভ সাইন, মানে নেগেটিভ নাম্বার। তুমি যখন এটাকে নেগ করতেছো, তার মানে তুমি এক্সপেক্ট করো যে একটা পজিটিভ নাম্বার পাবা, তাই না? কিন্তু আলটিমেটলি তুমি একটা নেগেটিভ নাম্বারই পাচ্ছো, এখানে এমএসবি এর 1, এই কারণে এখানে ওভারফ্লো ফ্ল্যাগ 1 হবে। বুঝতে পারছো?
Yes sir.
That's it. Okay, anything else?